This video will focus on defining the difference between acids and bases in terms of their general characteristics, and then also reviewing how to name both acids and bases. So when you think about an acid or a base, potentially lots of different things come to mind. What I always like to start out with is just kind of grounding you in what you're exposed to every day that could be considered acidic or basic. So for your acids, we've got like most fruits, oranges, grapefruit, grapes, red bell peppers are acidic. Vitamin C is an acid, vinegar is an acid. Okay, a lot of food type items we see listed under acids. For bases, you're less used to what could be basic. Soaps and cleaners are bases. A lot of stomach type medicines, Pepto-Bismol or antacids, those are actually bases. Okay? So you see right away, acids are food products, bases generally are not. Now we have some foods that are bases, pure chocolate, coffee, things like that have base properties to them. So what are the properties of acids and bases? Let's start with some acids. Acids taste sour. So if you go back to that list of things that are commonly acidic, you'll find that they all have a similarity that they taste sour. If you get an acid on your hand, it actually just feels like water though. And while we don't recommend, obviously, nowadays eating anything in lab, something a lot of scientists used to do is actually taste their chemicals to determine what type of material it was. So they would actually taste acids and taste the sour taste and end up with chemical burns in their mouths and things like that. So not just food items are taste sour. If you were to taste hydrochloric acid or sulfuric acid or something, it would actually taste sour to you. But it doesn't feel any different than normal water, which is why it's a little scary and dangerous because we don't know what's in it just by looking at it. In terms of its chemistry, it corrodes metals. As a byproduct, then it produces hydrogen gas, so it bubbles when you have hydrochloric acid with metal. Acids are electrolytes. Okay, they dissociate into water and allow electricity to run through the water, so they're considered electrolytes. Sometimes strong, sometimes weak, but they will make ions in solution. In terms of the pH, acids have a pH of less than 7. Okay, so if you had pH paper or litmus paper or something, you could determine the range for your acids. And actually with litmus paper, just like we were doing in the qual lab, acids turn blue paper red, and that's how you know they're acidic. Acids, as I'm sure you're aware, can cause severe chemical burns. Okay, they essentially dehydrate whatever they come in contact with because they're breaking that water and making that hydrogen gas. And they get hot, right? So they actually create a burn just like you would normally have from like a fire burn, but it's a burn from a chemical. So let's look at bases and compare these two. While acids taste sour, the bases actually taste bitter or kind of chalky in texture. If you ever had pure chocolate, it's like baking chocolate instead of normal chocolate, like delicious chocolate you get from the store, without the sugar, you can definitely taste the bitter and feel the texture of chalky. Different than acids, bases actually feel slippery like soap. So there's this very signature feeling to them if you were to get them on your hands. They're electrolytes just like acids are, so in solution, bases dissociate, creating ions that allow electricity to run through that solution. We got a pH of greater than 7 for bases then, the opposite end of what the acids are. Again, in the qual lab, we discovered that for bases are blue, so they make red paper blue. And then something you may not be fully aware of, I've mentioned it numerous times in class, bases can cause as severe chemical burns as acids. Okay? It just depends on what concentration you're working with in terms of which one will happen. I don't know if this dates me or if you guys have seen it. It's probably an R, but Fight Club had a scene where Edward Norton, his hand is burned by Brad Pitt using a base because lye, which is sodium hydroxide, is used in the production of soaps, right? Because bases are in soaps. So you can get as severe a chemical burn using a base as you can an acid. It's just a question of concentration of the ion once it dissociates in solution. All acid-base chemistry will be done in solution. Okay, your acids and bases are always in water, so be aware of that. We're dealing with all aqueous reactions. And these are always reversible. Okay, they're reversible depending on condition, but they're generally considered reversible reactions.